Hi Roselle. Here is my solution for you for that question. That's a tough one. I'm surprised that they're giving that to you in this course, but here's what they're doing. When you find an inverse, which is what the notation f to the minus 1 at x means, it means that you're switching x and y in the equation. So if we rewrite this equation like this, then what we want to do is put an x everywhere there's a y and a y everywhere there's an x. And I know you've probably talked about inverses in class, so I assume that you got that part there. So normally what we do then is we try to solve this equation in terms of y so that it ends up saying y equals something something x plus 5 or whatever. You can't do that for this equation because of the exponents on the y's. You've got y to the 7 and y to the 3. So the best you can do, and this is where the substitution part comes in that they gave you for the second part, the best you can do is we could solve this equation for y to the 7th, and that would be x minus 2y cubed. And then we could say, well, then y would be the 7th root of that whole monster on the right-hand side here. Or we could solve the equation for 2y cubed, and I'm going to leave it as 2y cubed for a reason. You'll see why in a minute. And that would give us x minus y to the 7, or 2y equals the cube root of x minus y to the 7. Okay. So the reason I did that is that now we need to evaluate this thing at 13 to the 7th plus 2 of them at 13 cubed plus 1. So what that's going to look like is we're going to have the 7th root of 13 minus 2y cubed all to the 7th. Because that's what y equals if we write it in terms of the 7th root and we solve for that y. And then for the second one, we're going to have plus 2 times. And this one we're going to switch over and we're going to use the other form that we found, which is this one. And that's already in the form 2y, so we don't need another 2, and that's my mistake. Let's get rid of that 2 there and start over. Okay, so we're going to have plus the cube root of x minus y all to the 7th, and then we're going to cube that one because it tells us to cube it, and I could have put the 13 in instead of x there, couldn't I? That would have sped things up a little bit. There's our 13. Okay, so I hope you're with me so far. So what I did was I used the two different versions of being able to solve for y from the inverse. And I know there's still a y on the other side, and that's the tricky part. And I used those to sort of match what the question gave you, because I knew that there must be a trick there, that they were going to want us to do something. When I saw the 7th in the cubed, I knew that it was connected to that y to the 7 and y cubed that we end up with here, and that they knew that there was no way we could solve for just y by itself. And I think there's a plus 1 on the end of this as well. Okay, so it gets a little more interesting, because when we take the 7th root all to the 7th, then it's going to just release that from all of those square root brackets. And when we take the 3rd root of the 3rd to the 3rd, then that's going to release that from the square root brackets. And I have this now. And so at this point, we can actually add up our like terms. 13 plus 13 plus 1 is 27. And it looks like I have minus 2y cubed minus y to the 7th left over. And I still need to go back and find an answer for those guys to substitute back in so that I can get a final answer. So luckily, let's just move this up a little bit. That didn't work. There we go. Oh, that made a mess of things. I didn't want to do that. Shoot. I want to keep that there so that we can see where it's coming from. So is it okay? What I'm going to do then is I'm just going to write over here to carry on. And what I'm going to do here is just use a little trick because I've got 2y to the cubed already defined as x minus y to the 7th. And then I'm subtracting y to the 7th. And so what's going to happen here is I'm going to have the 27 minus the x minus y to the 7th. And the important thing there to remember is that that's all in brackets because we're minusing the whole term. And then minus y to the 7th. And you see what's coming? The minus minus y to the 7th is going to give us a plus y to the 7th. And then we have the minus y to the 7th. And those guys are going to cancel each other out. And we just have 27 minus x. And remember what x was? It was 13. And so 27 minus 13 is 14. And I'm feeling good because I did this question twice now and I got the same answer both times. Yay! So I think that's the true answer that we need for this one. So that was a bit of a monster for you guys to be doing at this level. I'm hoping that you understand the steps that I showed you here and that's clear. But it's really very, very tricky for you to sort of see your way to what you have to substitute in each case to make this work. The big clue was in looking at the second part where it said evaluate the inverse at 13 all to the 7th plus 2 times the inverse all at 13 to the cubed. I knew when I started rearranging this, when I got this one and this one, that that's exactly what I needed to do was to substitute those in to that particular equation because it was going to work out nicely. That's why it was written like that. So I hope that helps. Email me back if it doesn't. Okay, I'll check again tonight.